Okay, this is 3.5 homework. First problem is a tough one. We have to solve this equation. It says there are two possible solutions, so I would just try some things. There's probably different ways to solve this, but I would multiply both sides by the natural log of the square root of x, so that we get 2 times the natural log of the square root of x, and I'll write x as x to the 1/2 power. And then I'll do the same thing here, only I'll write this in parentheses, the 1/2 power. And I'll bring the exponent down here. So I have natural log of x, make sure this is in parentheses. That's a very different thing than putting the exponent on just the variable. When you bring the 1/2 down, you get natural log of x, because 2 times 1/2 is 1. And then I'm going to subtract this to the other side. This would be minus natural log of x to the 1/2 equals 0. Now, this is the tricky part, but if you imagine this is some variable, like imagine that's w, then this would be the square root of w. So if you imagine that this was w squared, then this would be w. So that's the same pattern where you're decreasing the exponent in this way. So I'm going to call w equal to the square root of natural log of x, which is right here. That would be w. And then w squared would be natural log of x, which is right here. So then I can just solve that equation, and then from there I'll have w, so I can solve these equations. So factor out a w, and you get w minus 1 here. And then I'm going to insert back in what I called w, which w was the square root of the natural log of x. And so now I'm going to solve these. Basically, when the square root of a natural log of x is 0, then this thing's 0. So I could square both sides and get that's where the natural log of x equals 0. And then from there, change an exponential form, so it'd be e to the 0th equals x. Well, e to the 0th is just 1. So the natural log of 1 gives you 0. So the answer I'm looking for is 1 for x. Is one of the answers. The other answer then is what we get when we set this equal to 0. So I have the square root of the natural log of x equals 1. If I, set this equal to 0, add 1 to both sides. Square both sides, you get natural log of x equals 1. And then e base to the exponent equals the argument. So the other answer is e. X equals 1 and x equals e are the two answers. And you got to check both of those because we have to look for extraneous solutions. So it wants a less than b, so it'll be 1 in e because e is 2.7. And you have to check to make sure these solve the equation. So if you plug in 1 here, that's extraneous, and the reason why is because the square root of 1 is 1, and the natural log of 1 is 0. We know the natural log of 1 is 0 because e to the 0th equals 1, right? So anything to the 0th power gives you 1 if you change it in exponential form. So the natural log of 1 is 0, so we can't have 0 on the bottom. That's undefined. That doesn't solve the equation. But e works fine. If you plug in e up here, you get natural log of e is just 1, square root of 1 is 1, over natural log of the square root of e. If you bring down the square root as the 1/2 in front of the log, and the natural log of e is 1, you have 1 divided by 1/2, which is just 2. So this works fine. All right, the next problem is a little bit easier. We can factor out a 2 to the x from both of these. It leaves us with x squared minus 2 equals 0. And then we can just set both these equal to 0 so to solve this for the solution. So 2 to the x equals 0. Well, there's nothing I can raise 2 to get 0, so that doesn't help us. But I can get 2 zeros from this one. It's a quadratic. X squared equals positive 2 if I add 2 to both sides. Set equals 0 and add 2. Square root, you get x equals plus or minus the square root of 2. So let's put minus square root of 2 here and positive square root of 2 there. Okay, the next problem then, we're going to solve these log equations, so put them in exponential form. So we have base to the exponent equals the argument. And then we can just raise both sides now to the 8 over 7. And that will give us our answer. The 8's cancel, the 7's cancel. So we get x equals 128 to the 8 over 7, which should give you 256. And then same thing with b. This time we're going to change into log form from exponential form. So we have log base 8 of 5 equals 7x plus 3. So we're going to subtract 3. Log base 8 of 5 minus 3. Make sure you know this is in parentheses. And then we're going to divide the whole thing by 7 in order to get x. This is something we can do in our calculator, and if we do, we get negative 0.318 approximately. Okay, the next problem, we're going to solve this. So I'm going to rewrite this e to the 2x as e to the x squared, because I know I can do that, just multiply the 2 to get back to this. And the reason why is because it helps me see that if I were to call e to the x something else, like let's say it's some number, w, then if I rewrite it like this, then it's even easier to see that really what I have is a quadratic relationship. So if I solve for w, I can then solve for x. So this actually factors pretty nicely into x minus 3, or I'm sorry, w minus 3 and w minus 2. So my answers are w equals 3 and w equals 2. W equals 3 though is really e to the x equals 3, and e to the x must equal 2 as well. So from this, you can put it into log form. You know, natural log of 3 equals x is what the solution to this is. Take the natural log of both sides is another thing that works. And then here, I have the natural log base e of 2 equals x. So my answers are natural log of 3 and natural log of 2. And you might be able to enter those in just like this. If not, you'll have to do a decimal. Don't forget to check both of them, make sure that they work, but they both do work and are both solutions for me. If they don't work for you, though, make sure you say that they're extraneous. All right, this is kind of a tough problem. There might be other ways to do this, but I would take the log of both sides first, because then I can bring down the exponent. So then you can bring down the exponent and do 10x minus 5 times the log of 2, and it's log base 10, equals, I'm going to bring down the exponent on the other side as well, 5x minus 8 times log of 9. Then I would distribute both of these. So I have 10x log of 2 minus 5 log of 2 equals 5x log of 9 minus 8 log of 9. And then I would get the x terms on the same side. So I move this over and I move this over. And so I get 10x log of 2 minus 5x log of 9 equals, when I add this over, it's going to be positive 5 log of 2 minus 8 log 9. And then I would factor out the x. This is the key part right here to get x together. So I'll pull out 5x actually, and that'll leave me with 2 log 2 minus log 9 equals 5 log 2 minus 8 log 9. And then divide by this number, 2 log and 5 actually. 2 log 2 minus log 9. So on this side it'd be the same thing, divide by 5 times 2 log 2 minus log 9. And those would cancel. So the 5's, and I get x equals this quantity right here, which I can do on my calculator. I know it's kind of a pain, but if you do that in your calculator, you should get this decimal, 3.48. You might want to include, you know, a couple extra decimal places or something, but that's what I get with mine when I plug this in carefully. Okay, the next problem gives us this. I'm going to bring down the 2 here and make this 2 log of x equals log of x squared. Now, it says there's going to be 2 solutions, and I can see that I've got something, you know, log to the first power and then log to the second power, so it's a quadratic relationship, basically. I could divide both sides by log and get rid of one of the logs, but that would get rid of one of my solutions. So instead, I'm going to move this over and use the quadratic formula, or factor. So that'd be 0 equals log of x squared. That's some quantity squared. It's like a squared plus b squared, or b. So that'd be like minus 2 log of x if I move this over. So it's, you know, if I use a variable to make this look easier, if I call log of x w, this would be w squared minus 2w. So that's a little more familiar, but it's the same relationship. It's a quadratic relationship. I can factor out a w or factor out a log. I'll just go back to this form, so I'll factor out a log. and that leaves me with the log of x minus 2. And so I'm solving both of these for when the log of x is 0, and for when this quantity is equal to 0, or when the log of x is equal to 2. Those are the two equations I need to solve. This is 10 to the 0th equals x. So in this case, 10 to the 0th is really just 1. So x equals 1 is a solution. And then this is 10 squared equals x, so x equals 100 is another solution. I got to check both those and make sure they both work. And they do, so make sure you put the smaller one for A and the larger one for B. Okay, the next problem wants us to solve this, but we can't just enter this into our calculator because it wants an exact answer. So we're going to change it in exponential form. 8 to the x equals 1 over 256. And then obviously the base 8 is the key here. So we got to figure out how we can get 8 raised to some power to get 256. Actually, better yet, 2. I can make 8 2 to the 3 power. And I can make 1 over 256 2 to the 8th power. Okay, so then I can make this 2 to 3x equals, and I'll make this 2 to the negative 8. And then you can just compare right there. 3x has to equal negative 8. So divide both sides by 3. And there's my answer. X equals negative 8/3. And obviously that's the work I would need to see for full credit on the test. Okay, the next problem gives us this. This is tricky, but I always try to rewrite, when I have something in an exponent, I always look at that and try to rewrite it if I can. And you can rewrite this as e to the x times e to the first, because when you multiply like bases, you add the exponents to get back to this. So then I could subtract e to the x from both sides, and I can notice a commonality, e to the x, that I can pull out. And I have this. I can divide both sides by this number, so I have e to the x equals 8 over e to the 1 minus 1. And then I can take the natural log of both sides, or I could write it in log form. You have log base e of the exponent, or I'm sorry, log base e of this equals the exponent. Because the log is an exponent. And this is something you can do in your calculator to get a decimal that goes right there. I got 105.19 when I did this in the calculator. Alright, the next problem, 3 minus the natural log of 5 minus x equals 0. Subtract 3 from both sides. Multiply both sides by a negative 1. Change it into exponential form. And solve, so subtract 5 from both sides. And then multiply through by a negative 1. And it changes to every sign. And so plug this in your calculator, and that gives you negative 15.09 approximately. Okay, a couple more of these. We can make this log base 2 of 9 equals x minus 4. And then add 4 to both sides. So this would be plus 4 equals x. And that's something you can do in your calculator. And you can put right there. The next one, I can simplify this by knowing that the log of sum of two logs is the log of a product. So I can rewrite it like this, and then I can do e to the 5th equals x times x minus 6. And that's a quadratic I'm going to have to solve. So I'm going to have to do x squared minus 6x, and then subtract this number as the constant term over the other side. And so I'm using the quadratic formula now on this, where you have opposite of b plus or minus the square root of b squared minus 4ac all over 2a. And obviously it's going to give you an irrational answer, and it wants just one of those, so one of them must be extraneous. I got two solutions, 15.546 and negative 9.546. Now I can't use the negative because we know we can't take the log of a natural log of a negative number. You can try it in your calculator, but the reason we can't is, think about it. What does that equal? Well, it's e to the x equals some negative number, which we can't raise e to any number, you get a negative number, so that's out. It must be this